Hello, I think our next session should probably get started because we only have 15 minutes. Um, sorry, my everything just moved all around on me. Before I share the slides. So thank you for joining this fourth annual of the International Day of Women in Statistics and Data Science Conference with this year's theme, Thriving in Your Environment. We are recording the event and the videos will be available on the Caucus for Women in Statistics YouTube channel. We kindly ask you to post your questions to the speaker, who is me, Kendra Plord, in the Q&A chat. So let's go ahead and get started with that now out of the way. All right. So today I'm going to talk about designing cluster randomized trials. Um, this is in collaboration with Jean Teresi and Xiaoying Yu. We are all from different Pepper centers funded through the NIA. We all help a lot of investigators design randomized control trials. And with new complex designs, such as stepped wedge, we've seen an increase in the number of cluster randomized trials being designed and also just the desire to run a cluster randomized trial. And so we got together and we developed guidelines that we hope will help not only investigators, but also statisticians, especially statisticians if you're unfamiliar with cluster randomized trials and the issues with it. We hope that this guideline that we've created, that I'm going to go through very briefly today, will be a great resource to help the collaboration between researchers and statisticians to really discuss the pros and cons and whether cluster randomization is even needed for a given study. So first, what is cluster randomization? So here I show a site. So say you have a multi-site trial that you're trying to plan. The sites could be hospitals, they could be primary care clinics. And the first step is, well, one of the first steps is to think through how randomization should be done in your randomized control trial. So you could take a site, say that it's a hospital, and you could randomize individuals within each site. So individual randomization. Or we could take entire hospitals and randomize them to a treatment arm. So I'm going to go through a lot of the misconceptions of when a cluster randomized trial is necessary. One misconception that's commonly in the literature that we see for why cluster randomization is needed is that cluster randomization is more pragmatic or improves generalizability. And pragmatism really depends on several factors, and it does not depend on the unit of randomization. And generalizability depends on sample representativeness and trial conduct. So the solution here, ignore whether cluster randomization or individual randomization is needed in this case. If you want to assess how pragmatic a trial is, use the Precise2 tool, and I provide a reference at the end of these slides, to assess how pragmatic a trial is. In fact, most pragmatic trials are individually randomized trials. And note that the unit of randomization is not a criterion. And then for generalizability, consider what your study population is, develop strategies to enroll a representative sample, and work with collaborators to ensure the study design will maximize generalizability. Another misconception is that cluster randomization does not require informed consent. Even in the instance of minimal risk, informed consent may be needed. And in fact, cluster randomization makes figuring out who needs to give consent a little more complicated. And so we suggest that researchers and statisticians use the guidelines provided in the Ottawa Statement on the ethical design and conduct of cluster randomized trials. And again, I have a reference for that at the end of these slides as well. Another common misconception is that cluster randomization should be used if there is any risk of contamination. So contamination, if you're not familiar, that is when aspects of the intervention seep into the control arm, thus decreasing the effect of the treatment because you're making the two groups more similar to one another. And this is an issue, obviously, in terms of power, in terms of getting a clinically meaningful effect. So contamination is a major issue, but going straight to cluster randomization means that you're eliminating that risk of contamination, but you're introducing a lot of other issues. Correlation, for instance, because when you have a cluster randomized trial, individuals within a cluster are more similar to one another than individuals between clusters. And so you need to take into account that clustering. And that's usually through the intracluster correlation coefficient, or ICC, which I don't go into detail about today. I'm trying to keep this talk very general. But our guidelines go into depth regarding the ICC, how best to estimate an ICC when you're designing a cluster randomized trial. And then also, you're introducing potential sources of confounding and bias. So you are eliminating one risk of bias for a whole host of other sources of bias and confounding. And so only when the risk of contamination is severe should cluster randomization be considered. And we provide some solutions to help you figure that out. In general, we suggest to stick with individual randomization and develop strategies to minimize contamination, to measure contamination during the study, and then to adjust your sample size. And so this usually means, of course, powering for a smaller effect size. So an increase in your sample size. Researchers can utilize analytical expressions developed by Hemming et al. To assess whether cluster randomization or individual randomization is more efficient. And when I say more efficient, I mean in terms of total sample size. So there is a point that if you are adjusting for contamination under individual randomization, you may actually find that you require more participants in your study than you would in a cluster randomized trial. And so Hemming et al. Developed analytical strategies for you to find that exact contamination rate at which cluster randomization actually becomes more efficient than individual randomization adjusted for that contamination. So when should you use cluster randomization? Only when you absolutely have to. And so there are a couple main reasons, at least in our experience, when cluster randomization has been necessary. And that typically arises from the intervention itself. So for instance, if you have hospitals, like as I mentioned earlier, where we have multiple hospitals that we are trying to design a randomized control trial for, and our intervention is a policy change. Well, a policy change gets instituted at the cluster level. So it's infeasible to randomize individuals within each hospital to a different policy. And then in some cases, financial, logistical, feasibility constraints may make cluster randomization the only practical option, despite its trade-offs. So here, I just want to give a brief look at different types of cluster designs. The most basic is the parallel cluster randomized trial, where the dark gray is the treatment condition and the light gray is the control condition. So you have half of the clusters randomized to receive an intervention and half to receive the control. You could also have a longitudinal parallel trial where you're repeatedly sampling within each cluster over time. And then I have more complex designs. So a standard crossover design where you actually switch back and forth between treatment arms. Stepped wedge, where you can see that you have this progressive crossover to the intervention until at the very end, all clusters are receiving the intervention. And you can see where that name comes from because it looks like the steps. And then a staircase design, which is a more efficient type of stepped wedge design. It came from stepped wedge. And then you could have a batched step wedge design, which is essentially multiple stepped wedge designs within one trial. And so these are what we focus on in our guidelines. And I just want to give a brief introduction for this talk because next I want to go into focusing on stepped wedge because that is the most popular, complex longitudinal design that we see in our experience. Some of the misconceptions regarding when stepped wedge should be used. So here, one of the common misconceptions we see is that step wedge should be used when it would be unethical to withhold the intervention. So as I mentioned, step wedge allows all clusters to eventually receive the intervention. But if this is true, if it's truly an intervention that is very beneficial and should not be withheld, then it's unethical to withhold it until a trial begins or to make certain people wait until the last period to receive it. So our solution here, what should be considered first, is a parallel design with a waitlist control. And I have the little asterisks at the end of the control group to denote when the control group would receive the intervention. So you run your trial as a parallel cluster randomized trial, and then at the end of the trial, you can give the control group the intervention. This way, everyone gets the intervention if it's somehow needed for a certain trial. Another misconception is that stepped wedge should be used when a staggered rollout is needed. And you can see the staggered rolling out of the stepped wedge in the diagram. But crossover designs are not the only designs that allow for staggered rollout. You can use a parallel trial design still and incorporate a staggered rollout. And what's nice about the parallel design is that you keep that balance over time of control and intervention treatments. Whereas in the stepped wedge, you have potential issues of time variant confounding. And also time itself is a potential confounder because you can see most of the control is measured at the beginning of the trial and most of the treatment is measured at the end or near the end of the trial. Another misconception is that stepped wedge should be used to reduce the potential for confounding because clusters serve as their own control. Well, so I mentioned a little bit of this in the previous slide. So to go in a little more depth, crossover designs reduce the potential for time invariant, so baseline characteristics at the cluster level. So any cluster level characteristics that differ at baseline do get more controlled for in a crossover design. However, crossover designs introduce time varying confounding and time as a confounder itself. They're also more prone to disruptions, policy changes, pandemics. Those are a huge issue under a stepped wedge design, but not in a parallel design because you have that balance over time. So we suggest using a parallel design and utilize strategies such as covariate constrained randomization to increase the likelihood of balance on those cluster level baseline characteristics. You could also consider collecting a baseline outcome to account for potential imbalances in the analysis. So when should you use a stepped wedge? Well, when the study is not possible otherwise is our main guidance. And one example that's come up, at least in my experience, is when we have a very small number of clusters and the ICC, that correlation coefficient, is expected to be very large. A crossover design will likely yield more power than a parallel design. However, that additional power really comes from the repeated measures and not because of the crossovers. So we would suggest first considering a longitudinal parallel design, or you can add a baseline outcome on top of that, or just looking at a parallel design with a baseline outcome to help boost the power under a parallel design. However, in some cases, it's still not enough, and a stepped wedge is required in order to get that 80% power. So here, because of time, I'm going to go forward. I did mention a little bit about these parallel designs. So here I'm just showing you can incorporate a baseline period. And then, of course, the waitlist control, a staggered rollout. All of these things are available under a parallel design. So in summary, always use individual randomization whenever possible. If you can't avoid cluster randomization, consider a parallel design first, and only use a crossover design if a parallel design is not possible. Our commentary will be submitted in the coming weeks to medical care, so be on the lookout. Hopefully this will be a resource, as I said, to statisticians as well as their collaborators, the investigators they work with. Our hope is that this helps with communication between statisticians and the PIs that they work with to develop or to design more robust and internally valid randomized control trials. So I don't go through, we provide a flow chart to help with the design decisions. We provide tables with statistical definitions, mainly for the researcher, but this could be helpful to the statistician as well. We will go over the pros and cons of various crossover designs. And so because of time, here are my references, and thank you very much. Okay, don't see any questions in the chat. And I think we need to wrap up. So I will thank everyone for joining this session. Please be on the lookout for that guidelines paper if it's of interest. Thank you.